You've got a model that needs a GPU. Running it on your laptop is easy. Running it on Kubernetes, reliably, in production, is where people get stuck. Today, end-to-end, how to deploy NVIDIA CUDA workloads to Azure Kubernetes Service. Drivers, the device plugin, scheduling, and the gotchas that waste everyone's first afternoon. Here's the thing, GPUs on Kubernetes are not plug and play. A normal node just runs your container. A GPU node needs 3 extra things. The NVIDIA driver, installed on the host, a device plugin, that tells Kubernetes the GPU exists, and a scheduler, that places your pod on the right node. Miss any one, and your pod either can't see the GPU, or sits pending forever. Let's make all 3 just work. So how does a GPU pod actually work? Bottom to top, the node has physical GPUs. The NVIDIA driver makes them usable. A device plugin, running on every GPU node, advertises a resource called nvidia.com/GPU to Kubernetes. When your pod requests one of those, the scheduler finds a node with a free GPU, places the pod, and the runtime mounts the driver in. Your job is to get that stack in place, and on AKS, most of it is one flag. Before anything, 2 prerequisites. First, quota. GPU VM families almost always start at 0 cores on a new subscription. If you skip this, your node pool will fail to scale. Silently, request the increase first. Second, pick your GPU. AT4 is the cheapest. Great for inference and learning. An A100, for serious training. An H100, for the heavy stuff. Start small, you can always add a bigger pool later. Step 1, the cluster itself. With a plain CPU system pool, you do not want your GPU nodes running cluster add-ons and system pods. Those belong on cheap CPU nodes. So, create the cluster with a small CPU VM, then get your credentials. The expensive GPU nodes come next, in their own pool. Step 2, and this is the key decision. You add a GPU node pool, and you choose who installs the drivers. Path A, let AKS do it. Add the pool with a GPU VM size, and AKS automatically installs the NVIDIA driver and the device plugin for you. Nothing else to run. Path B, install the NVIDIA GPU Operator yourself. You add the pool with GPU-driver set to none. That's the new flag. The old skip driver install tag was retired in 2025, and then Helm installs the operator, which owns the whole stack. So which path? Path A, AKS-managed, is the fast answer. If you just want your model running, use it. Path B, the GPU operator, gives you control. Pin a specific driver version, partition a GPU with MIG, or export detailed metrics with DCGM rule of thumb. Start with path A, move to the operator when you actually need one of those things, not before. Step 3, verify. Before you trust it, 2 checks. First, does the node advertise the resource? Kubernetes should show nvidia.com/GPU as allocatable on your GPU node. Second, run the real test. A tiny pod, a CUDA image, and the command nvidia-smi. If it prints the GPU table, the whole stack works. Driver, plugin, runtime, scheduling. If it doesn't, you fix it here, not after you've deployed your model. Step 4, deploy your actual workload. It's an ordinary deployment, with 2 additions. 1. In resources, under limits, request nvidia.com/GPU. 1. That single line is what gets your container a GPU. 2. If you tainted your GPU nodes, and you should, so CPU pods stay off them, your pod needs a matching toleration, or it'll sit pending forever. Add those 2 things to your normal manifest, and you're serving on GPU. Now the gotchas that eat everyone's first afternoon. 1. The taint and the toleration must match exactly. This is the number 1 reason a GPU pod stays pending. 2. By default, one pod takes one whole GPU. To share a GPU across pods, you need time slicing or MIG, through the operator. 3. Your container's CUDA version must not exceed what the node's driver supports. And 4. nvidia.com/GPU only goes under limits, never requests. And a word on cost, because GPU nodes are not cheap. 2 levers. First, scale to 0. Enable the cluster autoscaler on your GPU pool, with a minimum count of 0. When no GPU pods are running, the nodes disappear, and the billing stops. Second, for training that can tolerate interruption, use a spot node pool, the same GPUs, at 60 to 90% off. Idle GPU nodes are the fastest way to burn a cloud budget. Quick recap. GPUs on Kubernetes need 3 things: the driver, the device plugin, and scheduling. On AKS, Path A installs the first 2 for you. The GPU operator is there when you need more control. Verify with nvidia-smi, request the GPU resource under limits, match your tolerations, and scale to 0 to control cost. This is the deployment stage of MLOps, the moment your model stops being a notebook and starts serving traffic. That's CUDA on AKS, end-to-end. The commands and manifests are in the description. If this saved you an afternoon, subscribe to AI Ops Academy, and I'll see you in the next build.